Good afternoon everyone, myself Himaja. So let me start explaining the FCF scheduling. CPU scheduling is a method used by the operating system to decide which process should run next on the CPU. Since there are multiple processes the only one CPU may be available. Scheduling helps in improving CPU utilization, reducing a waiting time, increasing throughput, and managing fairness between different processes. So this first come first serve is FCFS is the simplest CPU scheduling algorithm, which processes are executed in the order they arrive, and which is even called as an arrival time. Works like a queue, first in, first out. It is a non-primitive where once a processor starts, it completes without any interruption. It is very easy to implement but may cause a convey effect. Long process delays, shorter ones. This main objective is to design an FCFS scheduling simulator and create a C programming. I choose a C programming where it is very easy to run. It has different burst times and it has an arrival time, and it analyzes on first come first serve. There are different experimental setups. The different experimental setups are program language that is used, and tools and environment, dataset description. The programming language that is used is the implementation of FCFS first come first serve scheduling algorithm is done using the C programming language. Here C is chosen because it has faster execution, easy handling of arrays and structures, precise control over memory, and algorithm simulation. So because of this C programming is used, and which makes implementation very easy and understandable for me. And I have used a C compiler as a tool where it executes in a proper way as same as a dev C++, and which is very easy to compile. And I have used both Windows and Android phone here. So this C online compiler is nothing but programized in where you can get in Chrome, or you can even get in different browsers. The data description here. The data description is for each data set consists of different processes, 4 processes, and for each processes the files are arrival time, burst time, and process ID. Where by these process time and the burst time will calculate different times. The arrival time is defined as the time at which the processes enters the ready queue. Burst time is CPU execution time required. Process ID auto assign in P1, P2, P3, P4. The datasets were entered manually, time during the program execution. The implementing steps. There are different implementation steps. Those are step 1, start the program, where by including all the necessary header files like studio.h, and define a structure with a proper processes to store. Process ID, burst time, completion time, arrival time, start time, waiting time, and turnaround time. The second step is input number of processes. The program asks the user to enter the number of processes, so we can enter the how many number of processes we need, and an array of structure is created to store details of each processor. Step 3. Take an input for each processor. For each processor, assign an ID P1, P2, P3. Read arrival time, then burst time. Sort the processes by arrival time. It is of step 4. Then sort the processes in increasing order of an arrival time. Then process comes first, gets CPU first. Then calculate this scheduling parameter, which is a 5th step. So we'll calculate different times. I have said you before, and starting time is calculated. That depends on a CPU. If CPU is idle, then starting time is equal to arrival time. If CPU is busy, then starting time is equals to current time, where ideal is nothing but free. Completion time is calculated like starting time plus burst time. Then the turnaround time is calculated, control time minus arrival time. Then the waiting time is calculated, turnaround time minus a burst time. Step 6 is a display output where each table is calculated, then the averages are calculated for each table. The flowchart for this is starting a program, then input of number of processes, then input arrival time, burst time for each processes, then sort the processes by arrival time for each processor, starting time, complete time, waiting time and turnaround time. Then display table, calculate averages, waiting time and turnaround time, then end up. This is a code where C programming language that I have used. So let me explain a programming language. So let me explain a programming for this first come first serve. Here hash includes studio.h. It enables the input and output functions, and the next comes a struct process where this stores all details of a process, ID, arrival time, burst time, starting time, completion time, waiting time and turnaround time. Then int main, it is a main function where program execution starts from here. Int n where int n where it reads a number of processes, like printf. This is a statement where we have to enter the number of processes which comes in an output. So next, struct process p of n, where it creates a processes array to give a perfect structure. For I end of I is equals to 0 to I is less than and to I increment, where here the second p of I dot id is equals to I plus 1. It sets a processes numbers. Then it scanf statement tells reads arrival time, and this scanf reads the burst time. This reads the arrival time and takes the arrival time. This takes the burst time of a print statement, and this reads a burst time number. Then it starts looping. Looping arranges processed by arrival time. Here first come first serve. So we'll sort according to an arrival time, where current time is equals to 0. Current time is equals to 0. It is a CPU time counter. P of I dot st starts time of processes. P of I dot ct is equals to starting time plus burst time, where completion this defines a completion time. This is a turnaround time where completion time minus arrival time, and this is a waiting time where turnaround time minus a burst time. These are all the formulas where here current time updates a CPU time. Because of this statement it updates a CPU time. This is a formula where it adds different types of tools, and this print processes a table. This average weight with these print statements, here execution of program where average waiting time and a turnaround time is calculated and displayed. This is a statement. So and while we execute run, we'll get an output like this. Enter a number of processes, we'll enter 3, then it will ask automatically P1, P2, P3, and we have to type burst time and arrival time of 3 processes, as I have entered 6, 7 and 9 of a burst time, and arrival time is 1, 2, 3. According to an arrival time, it arranges in an order like ID 1, 2, 3. Then it gives an arrival time, then a burst time, then it calculates a starting time with a formula and calculates a completion time with a given formula in the program, and waiting time according to a programming formula, and then turnaround time where according to a formula. Then with this table it calculates the average waiting time and average turnaround time. So let's see the observations of this. This is an output that I have took for a 3 data sets, and the observation: the FCFS executes process in the order they arrive. If a long processes come first, all others wait longer. Waiting time and turnaround time depend mainly on arrival order. CPU becomes idle only when no processes has arrived. FCFS is a simple but efficient for processes with varied burst times. Average waiting time increases when early processes have large burst time. This is an observation. And the next one is comparative evaluation. I have taken here 3 data sets where having all arrival time same and having different arrival time, and a priority wise. The third data set is priority wise. With this arrival and time and burst time, have directly calculated waiting time, turnaround time for these 3 data sets. Then the comparison table for this is written here. I have taken average time, average waiting time, average turnaround time, context, switches and remarks. Here first data set is moderate waiting, the second one is improved performance, and third one is high waiting time and poor efficiency. So the conclusion of this is FCF is not recommended for real-time applications. Instead, SRTF provides the best performance with lower waiting times and a faster response, but it is very easy to implement. Thank you.